Okay, let's talk about units and dimensions. So units and dimensions, I know you're all at various levels regarding this subject, but by the end of this class, this should be an area of proficiency for everybody, and it should be a skill that is well under your belt. If any of this seems rusty to you or new, I would definitely pause here and spend a little time studying and trying to memorize a lot of these quantities, if possible. Soon after this lecture, I'm going to assume that everybody has these down pat and can recall these at the tip of your tongue. Okay, so we all know what dimensions are. They're listed here. So they're things like length, mass, time, so on and so forth. And depending on the unit system you use, you can get various units to quantify the dimensions, okay? And we all are familiar with the SI unit system and the traditional system. It's also known as the English unit system or the British unit system. Okay, so these three, length, mass, and time, I think these are kind of a no-brainer for everybody, or at least they should be. So length, we know we quantify that in meters or feet. Mass would be kilograms or slugs. So mass in the English unit system can take many forms. So slug is the one that's most commonly used in this textbook, but it's also very common to see pound mass as well. So we'll talk about the difference between the two in just a second. And time in all unit systems is in seconds. Okay, then there are these quantities that will come into play very heavily in this class. So force, hopefully you all remember in the SI unit system is newtons, and traditional system is pound force. Again, there are other measures of force that can be used here. But pound force is the one that's most commonly used in this particular textbook. Okay, pressure is quantified in pascals in the SI unit system and pounds per square foot in the traditional system. Density, volume, power, so on and so forth. Let's move to the next page and talk a little bit more in depth. But first, what I want to talk about first is what is so special about the pound mass? Okay, so remember the unit of mass in the English unit system is pound mass or slug. The reason why pound mass is useful is because 1 pound mass will exert 1 pound force at sea level. Okay, so in other words, something that has a mass of 1 pound mass will have a weight of 1 pound force at sea level. Okay, and that's why you often see it in many disciplines, including thermodynamics and on occasion fluid mechanics as well. Okay. All right, let's compare and contrast that to a slug. So what is so special about a slug? Okay, and the answer to this is the following. So hopefully from physics you remember that F is equal to mass times acceleration. And the slug has the property that the units will just work out to the force unit in the English unit system if you use slug. Okay, so in other words, force is equal to mass times acceleration. And in the English unit system, the unit of force is pound force, and that's equal to a slug times foot per second squared. Okay, so if your mass and acceleration are in the units indicated on the right, then you can just simply multiply them together and you will automatically get a pound force. Okay, if your mass were not in slugs and were in pound mass instead, then obviously you would have to convert from one to the other before you can plug it into this formula. Okay, so hopefully that is clear. And hopefully you can also see what the conversion factor between pound mass and slug would be, just because we know that the gravitational acceleration is 32.2 feet per second squared at sea level. So you can also see that 1 pound mass is equal to 1 over 32.2 slugs. All right, so you can keep that in mind as you move forward with the exercises and with the in-class assignments. Okay. All right, let's talk about pressure. Okay, pressure, or I'm going to put stress. Okay, so hopefully you've heard of pressure before, but stress might be a new term for you. But anyway, both pressure and stress have the same units, and they have the units of force divided by some sort of area. It might be a surface area or cross-sectional area, and we'll discuss those distinctions as we go on in the class. But anyway, you can see that if you work out the dimensions of this, force is going to be mass times L over time squared, and area is 1 over L squared. And then you can do some cancellation here. Okay, but hopefully you all see how to do the dimensional analysis that you're going to be required to do very shortly. Okay, in terms of units, let me talk about that a little bit. So in the SI unit system, we're going to talk about Pascal. Okay, and that is simply, you can see, remember it's force over area. It's going to be newtons over a meter squared. Okay, and hopefully that's perfectly logical and makes perfect sense. In the English unit system, remember we have pounds per square force. Okay, and if you want to just break that down and write it out, it's pound force over foot squared. Okay, and also very common is PSI for pounds per square inch, and as you would imagine, it's just pound force over inch squared. Okay, so that is pressure. Okay, let's talk about density. So density is going to be very important in this class, and we'll talk about it more in the next chapter. But density, hopefully we all know. By the way, the symbol for density is often that Greek letter rho, lowercase rho, is the mass over volume. Okay, by the way, in my handwritten notes, when you see that capital V with a line through it, that refers to volume. If you see the capital V, that refers to velocity, when it does not have the line through it. Okay, in dimensional analysis, we have m over L cubed. Okay, and in the SI unit system, as you would imagine, you're talking about kilograms per meter cubed. In the English unit system, we're talking about slugs per foot cubed. Okay, or as we discussed, it's also very customary to see pound mass per foot cubed. Okay, and last but not least, let's talk about energy and power. Okay, so remember, energy has the same units as work. And hopefully you remember from physics that work is the integral of FDS. So I'm just going to write here it's going to be proportional to the same units as FDS. Okay, so if you were to do the dimensional analysis, you'll see that force has the units of mass, length per time squared, and then we're going to multiply that by another length. Okay, everybody see that? Okay, so in the SI unit system, we have FDS is Newton meter, and that is defined as the joule. Okay, so the unit of energy or work in the SI unit system is the joule, and it's simply defined as Newton times meter. And in the English unit system, we have foot-pound. And that doesn't contract to anything, so we just write it like that. Okay, power. So power is energy per time. Oops, sorry about that. Okay, so in the SI unit system, it would just be joules per second. Okay, and that is defined as a watt. And in the English unit system, it would just be foot-pound per second. Okay, alternatively, if you have a rotating shaft of some sort, then you might also see it in a unit called horsepower. And there is a conversion factor between foot-pound per second and horsepower. So you should definitely be aware of that. Okay, and a couple other notes. You'll see that when there's analysis involving heat transfer, you can also use the BTU, which stands for British Thermal Unit, for a unit of energy or work. And then for power, you can also see BTU per second or BTU per minute, so on and so forth. Okay, but let me put that in parentheses because you won't see that much in this particular class, just because a lot of our applications won't involve that heat transfer piece yet. Okay, but you might see it in some of your other classes. Okay, bottom line from all of this, make sure you have access to a good conversion table. There is an excellent one in your textbook that you can use, and of course these sorts of resources are widely available on the internet. So I'll just write that here, conversion table. Okay, let me go back to this slide. So take a quick look at that table again, and hopefully you can understand where all the units come from and how they are named, and hopefully that should make the quantities a little bit easier to remember. Okay, and again, if this is rusty at all, please take a moment to study this right now and get this under your belt.